This is the AI Reader podcast. There have been cases where people have been falsely accused of using large language models to generate text, and some Luddites out there consider it to be cheating. However, the problem is not with the use of AI models, but with the inadequate AI detectors that are unable to distinguish between authentic and generated text. These witch hunts are causing real harm to the falsely accused. The often suggested solution to this problem is watermarking text output in a way that can be statistically correlated to LLM-generated output. Now you may be thinking, but isn't watermarking text output a form of steganography? Won't it be easy to detect and remove the watermark once people know about it? That is what I thought at first also. While watermarking is a form of steganography, there are techniques that can be used to make the watermark undetectable to the human reader, build it into the fabric of the output, and not significantly change the quality of the output of the text. I still think this is security theatre. Those that want to not be flagged as large language model output will sidestep this. This is a cat and mouse game, and my bet is on the mouse. I do appreciate the cleverness of their technique. Just like my grad slave days, I read the paper so you do not have to. Why don't you put your feet up and enjoy a nice cuppa? For context for future listeners, this podcast is being scripted May 10th, 2023, at about block 789,000 on the Bitcoin time chain. Oh, the joys of AI detectors. It seems they're nothing more than glorified random number generators at this point. And don't even get me started on the horror stories of false accusations. Old texts like the King James Bible, Magna Carta, and even the Bitcoin white paper have been flagged as AI written. It's enough to make one question the whole darn thing. Now, I know some folks like to talk about watermarking the text to prevent this sort of thing from happening, but let me tell you, my naive approach to watermarking was easily foiled. So I did a bit of digging and found a paper by John Kirschenbauer and his team at the University of Maryland called A Watermark for Large Language Models. If you're a bit of a tech whiz, you can dive into the nitty-gritty details yourself. But for the rest of us, let me break down the general idea of the algorithm in a less technical way. Watermarking text is basically hiding information within the text itself, which is a form of steganography. Steganography is a fancy way of saying hiding something within something else. It's like the chalk X on the mailbox during World War II, which signaled a dead drop was waiting at a different location. Only those who knew about the signal would even notice the signal, but anyone that knew about it could just go and erase it. Now, the clever thing about these AI-generated text watermarks is that each pair of words in the text is a watermark. Let me give you an example. The two-word phrase, the joy, would be AI-generated, but the delight would not be. And if we mark each pair of words in the entire text as either AI or not AI, we would get a statistical answer. It's like a game of spot the difference, only it's with words. Let's talk about how these clever large language models can actually watermark their own output. But before we get into the nitty-gritty details, let me give you a brief rundown of how these models work. And trust me, it's a topic for another episode, so I'll keep it short and sweet. Basically, these models use context clues to predict the likelihood of each word in their vast vocabulary to come next. For instance, let's try something fun with our very own ChatGPT. What do you think would be the top 5 choices to complete the phrase, keep calm and carry? Well, ChatGPT might suggest carry on, carry forward, carry through, carry yourself with grace, and so on. It might even tell you that carry on has a 95% chance of being the next word, as it's a pretty common phrase in its training set. But here's the kicker, folks. With more context, say a few thousand words, these models can adjust their predictions and suggest something completely out of the ordinary, like carry a lightsaber, if the phrase was uttered in a Star Wars fanfic. That's how powerful these models can be. Let's establish that there is a substantial, yet finite vocabulary of words or tokens at play here. Most of them have 0 chance of being the next word, but a few contenders are tied at about 2% likelihood of being chosen by the large language model. In normal circumstances, the model would randomly select one of these top contenders, giving a new twist to the regenerated response each time you hit the button. Thus, while the ideas remain the same, the wording will be different every time. The AI experts have developed an algorithm that assigns either red or green to every single two-word phrase in their vocabulary. Then, they instruct the large language model to only choose words that are labeled as green. So basically, this algorithm is like a picky teacher who only lets you use certain words in your essay. But instead of making your essay better, it just makes it more robotic. What does this mean for the generated text? It means that it will contain AI two-word phrases 100% of the time, even though a human writer would only stumble upon them about half the time. Now, these AI two-word phrases could be anything: midnight breeze, butterfly whisper, moonlit ocean, and so on. And avoiding them wouldn't compromise the text's meaning. But what if a phrase like Barack Obama wasn't on the AI word phrase list? That could pose a problem because Barack is frequently followed by Obama, and it would be weird to never use that phrase. To solve this issue, the researchers have implemented solutions like using three-word phrases for more variety or allowing the AI to use forbidden phrases in extreme cases. But even with these exceptions, a long text generated by the AI would still be watermarked as AI generated. Now, when it comes to watermarking, it's important to consider the threat model. Who are we defending against? Students who don't want to get caught using an AI essay, writers who know Google penalizes AI content, and job applicants who don't want their resumes and cover letters flagged. These are some real threats that we need to address. But here's the thing: watermarking isn't foolproof. The paper we're discussing today points out some weaknesses in their own algorithm, such as the ability to distort the output text in easily reversible ways. For example, having the LLM add an emoji between each word might be a way to throw off the watermark, then just remove the emoji from the output with a script. School kids have been taking the Wikipedia route, translating through several languages and running the result through a grammar checker to avoid plagiarism detection. In a battle between the engineers and the collective laziness of all teenagers in the world, my money is on the teenagers. What did we learn from teenagers and porn filters that makes us think they will not crack this in a few hours? So while the algorithm is clever, it's not infallible. It's like a cheap lock that only keeps out the honest people. Follow AI ReaderPod on Twitter and subscribe and like wherever you are listening. Until next time, keep calm and carry on.